This event that brings together several countries, including Greece, Egypt, Britain, Germany, Yemen, Azerbaijan, and more, in one forum for knowledge exchange and mutual development. Our seventh training session today is provided by Mrs. Noor Al-Shuwaili. A brief description about our lecture experience. She has a baccalaureate degree in petroleum engineering from University of Al-Basrah. She is a petroleum engineer with 7 years of experience in the oil field. Currently working and leading a Wellwork team in the subsurface department in Rumaila oil field. The team is responsible for to follow up rigless and rig workover activities with the well department, such as water shutoff, stimulation, ESP installation, integrity remediation, fragment, and etc. We here are delighted to have you, Mrs. Noor. You can start your screen and go ahead. Thank
Thank
you.
you very much for the introduction. Hello, everyone. I hope you can hear me clearly. Let me share my screen. I'm not expert on Zoom, but okay. Please let me know when you will see the screen.
Your screen is no, there's no screen.
Okay. Okay.
No, I can see it.
Okay. So now you can see the screen, right?
Yes, yes, we can see it. You can.
Okay. Let me just put it in presentation mode first. Okay. Hello, everyone. Thank you very much for joining us today to the session. So the topic that we are going to cover today, it's the production enhancement through well intervention, and we will be taking you through zonal isolation technique with cold tubing and workover operation. Firstly, just to introduce to you the activities that we are doing with the rig and with cold tubing operation. In this session, we will not be covering the equipment part, but we will be talking about one of the most important and critical operation that we are doing in Rumaila field, and also it has been done in all the other fields to increase the production, which is the zonal isolation activity. So you can see here, this is the rig workover. With the rig, we can do like a lot of operation that in summary, sorry, let me go and explain what the operation that we can do with the rig workover. Okay, so with the rig, any operation that require pull out of hole the tubing from the well bore and do the operation, we need to have a rig on site. Like, for example, if we need to run ESP or replace old ESP or failed ESP, if we need to do like zonal isolation while we have ESP in the well bore, if we have like integrity remediation that will require to pull out of all the tubing and then remediate the casing, especially if we have like shallow leak in the casing. If we have like some complex fishing operation, we need to do fracturing operation or stimulation, and also if we want to change some producer wells to injectors. So as I said, anything that will require to pull out the tubing from the well bore, we need to have a rig on site. For the operation that does not require to have the rig on site, which we will have like the tubing in a place in the well bore, and then we can run a cold tubing, which is like a pipe that we can run it inside the well bore. Through this pipe, we can do a lot of operation, and these operation are stated here. As you can see here, we can do everything that we could be done with the workover. It could be done with rigless, except, as I said, the operation that require like change out the tubing, like for example, the installation of the ESP or the complex integrity repair that require like some special equipment that need to be run with the rig. I see someone has his hand raised, so
I'm sorry.
should we receive
No,
question
no,
at
no.
this stage or let's wait
No,
for?
no. You can't continue. It's by mistake.
Okay, no problem. Thank you. Okay, so let's introduce the Rumaila introduction to the Rumaila oil field. Rumaila, as you can see here from the map, so Rumaila oil field is the biggest field that we have in Iraq, and I believe is the second biggest field in the world. In this field, we have like more than 1,000 wells, and these wells are split between injectors and the producers. In terms of the reservoir, we have like two types of reservoir. For me, I believe that we are lucky because we have like the clastic and carbonate reservoir. So we are facing challenges all the time by discovering these two, the intervention in these two reservoirs. And today we'll take you through all the challenges that we are facing in terms of zonal isolation in clastic and carbonate reservoir. This field is on production since 1954, and as I say, this is like, it's the biggest field in Iraq. In terms of the production, like it's now producing 1.4 million barrels per day. The last thing, which is more related to the pressure support, just as a general info, for clastic reservoir and carbonate reservoir, we have like mixed between the aquifer or between the injection water. Here, as I just explained, this is just to show you the activities that we could done with the coil tubing and the activities that we could done with Rig Workover. For our session today, we will be like specialized in zonal isolation technique with rigless, and also we will cover some of the zonal isolation technique with workover, so you can know the differences between both rig and rig workover. Sorry, rigless and rig workover. Okay. Okay, so zonal isolation. So what is the objective of the zonal isolation? First, we need to control the water. So the problem that we are facing in Rumaila field and most of the other mature field in the world, that when we see an increase in the water cut, then the well performance will start decline. So this is a sign to us that we need to do something to the well to improve the production, to increase the production. Because when we shut this water or reduce the water cut, we will end up having an increase in the production. So we have two objectives here. First is the reducing the water cut in a producer well. Second is to also control the water, but not in the oil producers. Here we will be targeting the injectors. And at the end of the session, you will understand more about the techniques that we are using to isolate water in injectors. Maybe you did not hear about that in your academic study, but you just keep in mind that we need to do sometimes zonal isolation in water injector wells, not just the producer wells. So what we are going to cover in this session, first, source of water identification. So we will understand in this session from where the water is coming and what are the techniques that we need to consider based on the water source. Secondly, we will cover the candidate selection process and also the water shutoff technique in clastic and carbonate reservoir. We will be covering the conventional method and unconventional method. And lastly, we will be talking about how we are going to evaluate our zonal isolation. Okay, so in terms of source of water identification, so the water from where it's come, it's either coming from the reservoir itself. Okay, but how we can like distinguish this water or how we can classify it? First, if we have like the oil here and the water, you know, like in the wells that we have aquifer support. So naturally, like the aquifer, so we are producing the oil, then the aquifer will like take a place and replace the oil that we were producing. Okay, So then in this case, we are expecting the water to reach to the perforation gradually and then start cutting water, like the case here. So here, this is something nature. It happened in all the aquifer, on all the wells that have aquifer support. So here we can classify the water source, like it's all water contact has been raised. The second one, which is related to the reservoir that we are doing, or that is relying on the injection. Because when we inject, because we don't have aquifer support, okay? So we are relying on the injector. So we have this injector, so we are injecting water in multiple layers, okay? But there is a possibility that one of the layer is the one that has high permeability, so it will be taking most of the fluid, and then we will see like water cut increase in the producer side. So keep in mind for all the wells that we have injection water, we will have like more concern of water cut rising due to the communication between injector and the producer. And this communication, it will happen quickly, especially if we have like some like conducted channel or fracture between the injector and the producer. Lastly, the other source of water that unfortunately we cannot do anything about it in terms of the intervention, which is the coning phenomena. This is when we are producing the well hardly, when we are putting higher drawdown on the well and we got coning. The only solution for this type of wells that we just need to reduce the total rate from the well, so then we can manage the conic phenomena. The other source of water that is not related to the reservoir itself, but it's also like affecting on the well performance. And today we will be covering some of the techniques that we'll be using to isolate the water. So if we have like channel behind the casing, and we'll show you that the technique that we are using to fix the channel. If we have casing damage, like if the well is producing nicely, but we have like damage in the casing or breach in the casing, shallower in a water zone or higher pressure zone, so then we need to know what are the techniques that we are going to use to isolate this casing damage. And finally, the backer leak, which is sometimes that when we are isolating some zones with backer, we might expect that the backer to get damaged, and we will be talk through this point later in the slides. I hope this slide is clear. And by the way, if you have any question through the upcoming slide, please feel free to put it in the chat or to raise your hand, and I will be checking this question like when we'll be going through the presentation. Okay, so in terms of the candidate selection, first, like as a petroleum engineer, there are some teams in the organization that their job is to check the well performance and check if the water cut is rising or if there's any change in the in it. Because if we have water cut that start to increase, then that means we need to do something to the well before we get it seized. I mean seized that when the well will not be able to produce naturally. Okay. We get sign that the water cut has increased. What will be the follow-up action? Is to run surveillance. I'm not sure here, to be honest, if you know a lot about the surveillance and the production logging, injection logging. So I will not go to the details for these logs, but as a simple explanation for them, it's a log that we are going to run into our wells to identify the amount of fluid that is going to be produced from each zone. For example, as you can see here, this is number 2. This is the run log to identify the water entry point. If you can see here, the water is the one in blue. The oil is the oil is in green. So you can see here, like from this log, maybe I know like you are not expert in how to interpret the log, but just keep in mind the one in water here, like you can see here from this log, the majority of water is coming from this zone. So simply like this log, we are running it to know how much water and oil is producing for each zone. If you go and check the reports for this production logging tool, injection logging tool, you will have, like, I can assume, like for this zone, we have like 1,000 barrel of water with 500 barrel of oil. Okay, so you will have these numbers in the report. Then we run the log, we know the zone that is getting, that is producing water. Okay, so what will be the next step? Then I need to think about, it's not just like subsurface, it's subsurface with wells. Need to think about what is the treatment design and execution. What is the best technique that I am going to use in this well? I am going to use cement, chemical, barkers. So we will know that through the presentation, but just keep it in mind, like the source of water, based on the source of water, we will be identifying the right zonal isolation technique. The last thing which we need to know is the evaluation of our job, because what is the value if I will do a job and I don't know if the job will be successful or not? So we can run also like some type of logging here just to identify if the job was successful or not. As you can see here in this slide, like the one in the that's highlighted in the slide was using water, but later when we run another PLT after we did isolated, it's not producing anything. So great outcome from the job. Okay, now let's move to the technique of the zonal isolation. First, please keep in mind, like, we are dealing and not just in Rumaila, and as I said, in the world, we are dealing with two types of reservoir. The sandstone reservoir, which we call it the clastic reservoir, which is just the general word that we can use to describe the reservoir, and also the carbonate reservoir. But in terms of the challenges, as I said in the previous slide, it's not the same. So the technique that we are using for clastic is different from the technique that we are using for carbonate rock. So now let's go and understand what are the things that we are doing in terms of the zonal isolation with the clastic reservoir. So here, in terms of the techniques, you have this well, we call it well A. This well has water. The water is coming from here and from here. Okay, to make it clear to everyone, I just put here some boxes just to highlight the zone that is cutting water. Okay, in terms of the method, we have two methods to isolate this water. First, the cement, which is like the routine jobs that we are doing in the field. The other technique that we are considering is pump chemical. We will talk through this chemical and why we need to pump some chemicals in some occasions, okay? Yes, so for the cement squeeze, you can see here in this diagram, like the source of water, it could be different. It depends on the well itself, on the reservoir type. You can see here, like, this well, we might have water coming from the bottom of the perforation. And the second well, we might have water coming from the second half of the perforation, okay? The third well, we might have water coming from the upper part and from the middle part. So you can see here in each example, we will have different challenges. And in each example, also, we have different techniques to shut off this water. But keep in mind, for the cementing operation, which is the routine operation, and at least in Rumaila oil field, like what we are going to do here is that we are pumping cement, Class G cement. And you can see here, this is the perforation tunnel before we pump any cement. And then when we will pump the cement and push it inside this perforation tunnel, we will end up having the cement in the perforation like this, in this way. And then this cement, it will be hardened and then will help to isolate the water, sorry. And it will help to isolate the water, okay. isolate the water successfully. And we'll know about that in the following slides. So just as a diagram to explain to you how we are going to do the zonal isolation. So here with coil tubing, we can explain by this animation how we are going to do the job. First, you can see here we have a well with two zones, okay? Two zones open. One of them has water, okay? So we are going with the coil tubing, spot the cement, okay? So we did that already now. We spot the cement across all the perforation, and we also put some cement as excess cement volume here. This is to help to be able to squeeze some cement into the perforation tunnel, okay? Then we'll start the squeeze operation. As you can see here, if you notice that the cement top has dropped here, if you can see. Okay, you see, it has dropped. Why is that? Because we were able to squeeze the cement into the perforation tunnel. How we are going to do that? So as I mentioned, we have perforation that are open. We spot cement across all the perforation. Then we start pump because we have now a closed system. All the perforation are covered with the cement. Nothing is exposed. Then we have just the casing, and there is here like color fluid. So what are we going to do during the squeeze operation? We will be pumping blind here from the coil tubing just to increase the pressure, okay? We will be doing hesitation squeeze, as you can see here in this chart. So we will be squeezing the cement or pushing the cement inside the perforation tunnel. Through this process, we will be pumping, then we'll stop. Then we'll be pumping again. The pressure will increase, we'll stop. Then we'll continue till we reach the maximum pressure. This maximum pressure, it will be identified based on the reservoir that we are dealing with and the fracture pressure. So the fracture pressure need to be taken in consideration. Okay, I believe till now everything is clear. So we did the squeeze, we push the cement inside the perforation tunnel. For coil tubing in specific, we don't have the ability to get a milling tool, which is like the milling tool. It's same like as a drilling bit when we needed to drill the reservoir of the wellbore. Here we have like, we cannot run the milling tool to mill long section of cement. So we have to identify a method that will be able to like take this cement out and have accessibility to the wellbore without leaving any cement inside, okay? So then there will be like a stage, it's called contamination. They will be pumping some fresh water, some gels to make sure that we will get all this cement out from the wellbore. As you can see here, no cement left in the wellbore. The perforations now all are closed. So what will be the next step? I hope if someone write it in the chat. Okay, we wait 24 hours just to make sure that the cement is hardened and it reached its full compressive strength. Then we run with the perforation gun, perforate the oil zone, and then put the well on protection. We need to do end to lift here to put the well on protection because we have color fluid in the wellbore. I understand this might be like there might be some complication, but please let me know if you have any question before we move on to the next slides. Sorry. This is just to show you like throughout all the job, the coil need to be inside the cement. So the placement should be like this and not like this. Okay, here we are going to talk about the type of cement that we are considering during the cement squeeze operation. But as I said, I would prefer to stop here for a few minutes just to take some question before we move on, because for me, it's really important that you understand all the steps here. Please, SPE, like if you could help with the questions, that would be great.
If anyone has any question, please raise your hand so I can unmute you or write your question in the chat box. I'll read it to Mrs. Noor. Ayhan is asking, what is coil tubing?
So coil tubing is sorry, I said in the beginning that I will not cover the equipment part, but as a simple explanation for it, it's the equipment that we are using. Okay, let me show you the picture. Equipment that we are using a coil tubing. Okay, this is this one. The coil tubing, which is like a tubing that we can, with the size of it, it's between 1.5, 1.75, it reaches 2-inch coil. And then through this conducted pipe, we can pump like cement, pump acid, pump nitrogen through it. It will have like PHA at the bottom of the coil tubing, and this PHA, depend on the job type, we are going to run like a special PHA or special nozzle. It depends on the operation. For cement, we are going to use something called fill bore nozzle, which is just to help to pump the cement. Sorry, where is it here? Yes. So here, this is the coil. You can see here that at the end, we will have like a PHA, which is here during the spot of the cement. We have something called like full bore nozzle. This nozzle will have like what is called like open port at the bottom, which we could pump the cement through it. And
There's
we will
another
have different PHA depend on the job itself.
there's another question. What about formation damage with CMT, which might happen through a CMT job as a steam, a very care for such operations?
Okay, so I will just go and check the question if you don't mind.
No, you
Okay,
can go ahead.
so thank you. Okay, so I believe we answered the question of coil. And regarding acid pump and squeeze, if I understand the question correctly here, I mean, I did not mention the details, but during the cement operation or before the cement operation, we are going to pump some acid to make sure later. But I did not mention a lot of details, just confuse you. I will answer this question in the upcoming slide. Yes, we can. There's a question about if we can remove the cement with the drill bit. Yes, what I was referring here quality, it's reducing oil. How we can pump cement? Good question, Ali. So as I mentioned, like regardless of the source of water, if it's coming from the top or from the bottom, the technique is the same, because we are going to isolate at the end. You will have this. Okay, so you will be squeezing everything, as you can see here. Then at the end, you will have all the perfs are squeezed. So if your water zone is at the top, you just don't need to perforate it. You are going to perforate the bottom zone. If it's the opposite, if you have oils of the water zone at the bottom, then you need to open the oil zone at the top with the perforation gun. I hope I answer your question. Okay, I believe we can go to upcoming slide and then we'll make another stop. Okay, so there was a question about the question about the formation damage. So if we are going to do cement operation, do we expect that we are going to like squeeze this cement inside the matrix or inside the reservoir itself? For clastic reservoir, this is, we will not be pumping the cement inside the matrix. The cement will go through the perforation tunnel only, as you can see here. This is misconception, which is that in people's mind, that when I will be squeezing the cement, then I will be losing cement, or the cement particles will go inside or deep into the reservoir. But this is wrong. The cement will stop here at the perforation tunnel. All the things that are going to go to the reservoir, which is called cement filtrate, which is like just water that was mixed with the cement. In terms of the cement types, so like class G is the standard cement recipe that we are considering worldwide. We have like different type of cement. What is the main thing that is changing between these types of cement? For example, here we have micromatrix cement. What is the difference between class G and micromatrix cement? Or maybe I can put a third cement. So all the things that will be different between type to type is the pore throat size, okay? Because for class G cement, the pore throat size, it will be between 30 to 100 micron. For micromatrix cement, it will be small, it should be smaller, okay? It's 5 micron. For sandstone formation, the pore throat size for sandstone formation, it's vary between 1 to 10. So to answer the question about the formation damage, if I have pore throat size from 1 to 10, how I would expect when I will be pumping cement with pore throat size of 30 to 100 micron to see like a penetration for the cement into formation? This is impossible. So if you want like a practical answer, this is the answer with the number. So you should not expect any invasion of the cement inside the matrix. Regarding the cement with the small particles, in some walls, when we have like some channels in the cement, okay, so you need this cement to penetrate through these micro channels. So it's better to use achieve better squeeze job. And I believe we will be talking through this in more details in the upcoming slides. Okay. We talked about the cement. I hope like everything was clear. Let's talk about the non-conventional method, which are the chemicals. Okay. First, when we think about a chemical, the first question that you should be asking yourself, do I need to pump a chemical that is going to go deep into the reservoir? Or should I pump a chemical that will stop in the wellbore? I don't need it to pump it deep into the reservoir. And depend on the well itself, on the reservoir itself. There are a lot of parameters that need to be checked. I need to agree with the surface companies on the chemicals that I need to isolate the water. Do I need a chemical that will go deep into the formation? Do I need a chemical that will go through like just like penetration? All these questions you need to ask them when you are designing the job. And also you should always ask the question about the chemical itself. Is this chemical going to damage the reservoir? Like I'm aware of some chemicals that if we pump it, we could not restore the productivity from it because it will cause like deformation damage. So all these questions should come to our mind when we'll be discussing the about that in the upcoming slides. Okay. These chemicals, there is 2 ways to pump them. First, if the chemical, let's assume that we are going to pump a chemical that is going to damage the zone, the water zone, okay? So if I have a chemical that I know by nature, this chemical is going to make a formation damage to my well. So should I pump it selectively or just go and pump it and let this chemical go everywhere? Sure, if I know that this chemical is going to damage the reservoir, I need to pump it with the packer, okay? This is the case in the, as you can see here. So we have a case when I want to isolate the bottom zone, which is, this is the zone that has water. And because the chemical that I am going to pump, there is a possibility of formation damage, then I need to protect the oil zone from any damage. So then what I'm going to do, this is the zone, then I will run a packer with the coil tubing and set the packer, as you can see here, across the casing. So then I have the ability to isolate the oil zone from the water zone and the ability to pump the chemical through coil tubing through this pipe down here to this zone only. This chemical, it will not reach the oil zone. Then here I start pumping the chemical while I have a packer in place. Then, as you can see, after we pump the chemical, I will deflate the packer. So deflate the packer means that because the packer, when it will be run with the coil tubing, first it will be like within the same size or close to the same size of the coil. Then it will expand and set inside the casing. So if I run like, let's say 3-inch packer, it will inflate to 7-inch. Then when I need to get it out, I need to deflate the packer, okay? And then deflated means that it will, like, the size will change from like 7-inch to like its original size, 3-inch, and then get it out from the wellbore. Here, we take the packer out, we left the chemical across the bottom zone. We did some clean out operation because this chemical, it's like, we have it in the wellbore, some of it in the wellbore, but the majority of it's in the matrix, okay? Then we have like, now that this chemical is not in the wellbore anymore, it's inside the matrix, then I can go and lift the well, because most, by the way, all the operation that I'm talking about now is need the well to be cooled first with the brine before I start the operation. So to get the well on production again, I need to like reduce the hydrostatic pressure, and I can see the reservoir fluids start coming to the to surface. So I need to pump nitrogen to reduce the hydrostatic pressure. So then here I will put the well on a production. Okay, I hope like this example was clear and you understand like all the steps. I don't want to make it like complicated. I can go and talk more about how we are going to run the packer, what is the mechanism of setting the packer, how we can make sure it's set, and how we are going to deflate it. But I just want to give you overview on all the zonal isolation technique without going to the details for each technique. Okay. In terms of the chemicals that we are going to use, so I just pick some chemicals just to show you. For example, the chemical that I did explain about it in the previous slide, you can see it here. So what is the beauty of this chemical? Here, as you can see, it's in a liquid stage. As you can see, it's pumpable. The viscosity is not really high. Okay, this is when we will pump it through the coil. Okay, then after we pump it, okay, here, after we pump it and let it set, You see the chemical, let it set, give it some time. As per the lab, you will know the time that you need to wait till you go and clean it. Then you should clean it when it reaches to, let's see. Okay, so as I said, this is when you will pump it through the coil. The viscosity is low. And then it will reach to this stage. You will give it some time. And then
16 hours.
You see here, he says 16 hours in the lab. And it's come like, I don't know what you call it here. How I explain it in English. It's like a gel. Okay. This is the final appearance for it. You can see here. This is what will be in the matrix, okay? This is what is going to plug your pore-throat, your permeability. And this chemical, by the way, is like, it's dangerous to pump it because it's difficult to get access to the reservoir again if we have some oil remaining. So this is why we need to make sure that the zone is fully swept and no oil left. Okay. The other chemical that I'm going to cover is also a polymer that we can pump to isolate or to reduce the water cut, but without thinking that we need to pump it selectively. We can pump it, I mean, from tubing, from cold tubing, without a need of any Parker, which is the opposite of the previous case. So the example for this, there is a chemical, it's called relative permeability modifier. This is how it looks, and this is the objective for it. So this chemical, if we have like a well with multiple zones, like this case, we have oil coming from the top, oil coming from the bottom, and water we have from the middle, okay? So this chemical, the relative permeability modifier, which we call it RPM, I mentioned before many times during the session that I had with the students from the university. Like, this is famous chemical. You can search on it on Google, and you can read a lot of articles or SPE paper on it. Anyway, so for this chemical, why I said we don't need to care if we need to pump it with a packer or not, because this chemical, it will not damage the oil zone. What it will do is to go to the water zone and plug the pore-throat in the water zone, and then you will see that in the video. You see here, you have a well with oil, water, oil. Then you will pump your chemical. By the way, for this chemical, as I explained, that this chemical, it will not go deep into the oil zone, while it's need to go deep into the water zone. It's designed to be going deep into the water zones, okay? Then it will work on it will be absorbed on the rock face. And it will reduce the permeability to water 7 to 10 times. Okay. Yes. Now we have like the chemical. It went to the zone that I'm targeting. And by the way, the penetration, this chemical to work, it needs to go deeper into the reservoir, between like more than 4 feet penetration. And if we did not achieve that, then we will not be able to reduce the water cut. Then when we will put the well on a production, we will see that the water has been reduced from the zone, while the oil and productivity did not change. So it's not permanent isolation. It's like a chemical that will reduce the water cut, but not fully isolated. Okay. Great. So we covered the zonal isolation in sandstone reservoir. I will stop just for a few minutes to check on the question before we move to carbonates. I'm just watching the time. We have still like many slides to cover, and I hope like you enjoyed the session so far. Okay. I'm just checking for SPE. I'm just checking some question. Okay.
Okay, you can go ahead. If you want to read, if you want me to read it, you can just ask for it.
No problem. No, I can read it quickly. Okay, why we using calcium carbonate with cement when mixed? I believe you need to wait for this question because we will be talking about the calcium carbonate in the zone in the carbonate reservoir. Okay. If we have previous sand production, we have cavity around the, oh yeah, if we have cavity around the casing, and this is, by the way, this is the case, one of the challenging that we have with carbonate reservoir, because we have like some caves that we need to, that will be taking all the cement or chemicals that we are going to pump. So it's not really the case in the sandstone, at least in Rumaila oil field. There is a risk. I mean, there is a question about the packer, a packer, and if there is a risk that we could not pass it from the tubing when we pull out of hole. Yeah, you are right. There is some risk, but it's not really big. For example, in our field, we just have maybe 1 or 2 cases when the packer, we were not able to retrieve it. And then we just push it down in the well. Okay, yeah, great point. Yes, the CPL is really critical, especially if we are going to do zonal isolation and we have doubt about the source of water. Yes, it will react with the zone that has water only. It will not react with the zone that has oil. How we identify the water cut zone exactly? It's us. I'm not sure. Maybe you did not join the session from the beginning. We will be running some logs, which we call them production logging tool, that we could know from it from where the water is coming. It will give us exactly the amount of water that is coming from each zone. Okay. Yes, so now let's move to the most challenging operation in Rumaila, and I believe in all the field that are dealing with the carbonate reservoir worldwide. By the way, for the a group of people that we have here from different countries, if you know about any specific challenges with the carbonate reservoir, please write them down in the messages for everyone, information and knowledge. Okay, so let's move to the carbonate. What is the challenges that we have in carbonate reservoir? First, for carbonate, to produce from the carbonate reservoir, we need to stimulate the wells. What's the meaning of stimulation? This session, actually, we are not covering the stimulation, but just like a quick explanation for it. So then you can understand the challenges that we are going to face with the cementing operation or with the chemical. So to produce from the carbonate rock, okay, so this is carbonate rock. Okay, sorry. I believe you need to mute. Okay.
Yeah,
Thank you.
I'm sorry.
Yes, no problem at all. So yeah, regarding the carbonate rock. So what we need to do to produce from this reservoir, we need to increase the permeability by doing the stimulation job, which means that we need to pump acid, okay, acid into this rock, this carbonate rock, to be able to increase the permeability, and then we can produce from this reservoir. This acid, what it will cause in the carbonate, when we will be pumping the acid, will create something called wormhole. Wormhole in Arabic, it's like tabab, okay? So these wormholes that we are creating in the reservoir, this is the process, or this is how we increase the permeability and produce from the wells. So we have to stimulate any carbonate reservoir to get a production from it, as simple as this. So one of the challenges that we have in Mishrif, that we are already having like stimulation job on the well, so we have this network of wormhole. This is the first challenge. The second challenge, and the well life, if you will be like checking the well life, you will see like the well was stimulated multiple times. So what that mean? If you stimulated multiple times, that means that you will increase this wormhole further, and this will complicate any well intervention operation on the wells, okay? This is the first challenge. The second one, which we have it, at least in Rumaila field, when we have a zone, we call it here, it's called veggie zone, or which is the zone that has very high permeability. Very high permeability, I mean it's over 1 Darcy, okay? It's reached maybe 6 Darcy or even more. So these vegs, what's the problem with them? That, I mean, they don't need acid to produce, and also these zones are like, it's like a cave, or it's taking everything. Anything that you are going to pump in a well that has veg zone, you would expect that this zone will be taking everything. You will, if you pump cement, you can come later and check if there is a cement in the well, but you will not find it because it was taken by the veg zone. So the veg zone is like a fracture, but we don't have fractures here in Rumaila, that is taking all the things that we are pumping into the well bore. So I'm just trying to explain, because this is really we need to have like a session for stimulation, but just to make it easy and simple, just keep these two challenges in your mind, which is the wormhole that is created by stimulation and the veg zone that is naturally in the reservoir, okay? When we'll be explaining how we are designing the job based on the challenges. Okay, so here in terms of the reservoir, or in terms of the well itself, in terms of the reservoir, let's talk about this first. You can see here, maybe most of you, like you are petroleum engineers, so you have studied about the injection pattern. So the injection pattern for Rumaila, as example, we have 9-spot pattern. What does that mean? 9-spot means that we have one injector in the middle, and we have one injector, 80 producers around it. So one injector will provide support to 80 producers. So if you recall at the beginning, when we talked about the zonal isolation, we mentioned that we have to deal with producer well, and you need also to think that we might need to do zonal isolation in injector well. And I mentioned to you to keep this, I remember this statement, because when we will reach to the carbonate reservoir, we have to remember it. So what are we going to do in injector? In a producer, we need to think about the injector as well, because any operation that we are going to do in any of the wells, it will affect the other one. So let's talk about these two examples in specific, and I want your thoughts to be in the chat, please. Okay, first, well B. We have a well. There was a question, by the way, before on the oil and water and how we can identify the water zone. So this is the production logging. So to make it simple for you, the zone that we have oil and water from it is the zone in the middle, and the one that highlighted in this circle, okay? But what is the problem in this specific well? Which is the challenge that we are having when we have injection and not aquifer support? That we have oil and water is coming from the same zone. Okay, what's that mean? If I want what we said before, that if we need to increase the production, we need to cut the water to help to reduce the hydrostatic pressure and then get more oil. So here, if we have oil and water in the same zone, for me, I mean, when I will see this log, I don't have like any option into I don't have I mean I cannot plan any water shut off here, because if I will isolate the water, I will isolate the oil at the same time, and this will affect on the production. So I should not do that. What I need to think about in this specific well, we have oil and water coming from the same zone. I know we have injection. We are relying on the injection here. So the treatment for this well, it will not be pumped through the producer well. I will pump the treatment in the injector well. Okay? Please, like I just want you to understand this slide very well, because it will help me in the it will help you in the understanding of the other slides. So if we have a case when we have oil and water coming from the same zone, we need to think about a technique or about a chemical that we need to pump, but not in a producer, an injector. Okay. For example, here, well C, this well from the injection, I mean, I know like maybe not all of you can read the log, but to explain it, that we know 70 or 80% of the water is taken by this zone, the zone that highlighted in circle. So if I know the water, all the water is taken by this zone, I need to do like intervention on the well, or pump chemical, cement, whatever, depends on the well type, on the job design. That will be, so the chemical that I need to pump here, I just need to think that I need to reduce the water in this specific zone to help us to reduce or to delay the water cut from the nearby producer. So please keep in mind that for any 9-spot pattern, 5-spot pattern, all the things that we need to do in producer, I need to think about the injector at the same time. So I always need to look to the pattern, all the pattern, before I decide on the intervention in any injector or producer well. I hope, like, because I spent a lot of time on this slide, so I hope it's clear enough. Okay, so what are the chemicals or what are the techniques that we are going to use in Mishrif? First, let's not forget what we have in Mishrif. We say that, oh, sorry, I said Mishrif because we call it Mishrif here, but let's use the general word, which is the carbonate reservoir. So we have wormholes, we have vaggy zone or fractures. So the cement itself, that we were pumping it in clastic reservoir and we did not get any issues, we did not get any cement lost into the formation. Here is the opposite. If you go with the cement only, whatever the type of the cement that you are going to use, you should expect that all the cement will be taken by the vags that you have in some zones, by this network of wormhole. So you will not find any cement inside the wellbore and any cement inside the perforation tunnel. So to design the zonal isolation in carbonate reservoir, you need to pump something ahead of the cement, which is chemical. This chemical, to fill these wormholes, to fill like the vags or the high permeable citric zone, fill them with some chemical to be able to pump the cement and squeeze the perforation tunnel. If you will not do that, then you should not expect the cement to stay in the wellbore or in the perforation. what are the chemicals that we need to pump to reduce the permeability here, or like to plug the some of this network or some of these bugs? For the chemicals, we have like different set of chemicals, but one of the chemicals that I believe it's used worldwide, we call it calcium carbonate, which is, this is the picture for it. It's like a particulate with different particle size. It's range between from 50 to 1000. And the design for the calcium carbonate, it will be based on some parameters that will be checked before the job. So we will be pumping this chemical ahead of the cement just to help us to reduce the permeability before we lost any cement into the perforation. And the beauty of this chemical, it's acid soluble. So whatever chemical that I'm going to lose into the reservoir, I have the ability to reduce, to like dissolve it later on with acidizing. This is also need to be kept in mind. If the chemical that we are going to use that will go through the matrix, is it going to be like permanent, or if there is any chemical that we could use to break it? This one, easy, acid will dissolve it, no problem. Okay, for the cement, we can use Class G cement, which is the same cement that we used before in the sandstone zonal isolation. But here we could like discover a new cement, which is like someone, like I believe he wrote in the chat about, could we use calcium carbonate with the cement? Yeah, we could. Here we have like some fibers. You can see here the fibers here. This is before it get mixed with the cement. You can see how it looks. And after it got mixed with the cement, you can see how it looks like. So we have like this is something called, like, it's a cement with fibers. I will not mention the name of the chemical just in case that I'm not allowed to. So just to keep in mind that sometimes we need to pump some chemicals with the cement itself to help to not lose the cement inside the matrix and to help us to achieve good zonal isolation. And this is video just to show you during the mixing. So this is the cement in the batch mixer. Then we have the fibers that will be pumped. And as I said, this will be the final look for it. Okay, the other chemical that we could also use, but this chemical is commonly used in injector more than producers, okay? Which is like the case here. When if you recall, like in the previous slide, we said that we need to do some intervention on the injector side to help us to reduce the water cut in the producers, or help us to delay the water cut from the producer wells, okay? And also to help to like divert some of the water to the lower water quality zones, okay? This chemical, as you can see here, it's looks like this water soluble polymer. If you can see here, and maybe it's better to go through the video and you can see it from the video. Okay, so you can see here, this is how it looks before we touch the fish water, before, okay, because it's gets swelling with water. This is after 5 minutes, 10 minutes. You can see this chemical is going to plug your matrix and reduce the permeability for it. So then we can follow up with cement, or maybe even without the cement. This should be remain in the matrix. So this is called like in the weight. Sorry, not that. So this is, it could like the weight will be increased by 300 times. You can see from this to this. And I use this chemical mainly on injector wells. Okay, this is just like a diagram to show you that this is, if you recall in the beginning when we talked about the communication between injector and the producer. So you can see here that we have the water, so that is producing from this well. So we are losing oil. So if we do treatment, okay, so now I pump the treatment. So this will help us to reduce the water that is going to the zone and also help us to get the water into the lower permeable zone. So then we can get oil from the other zone that is opened in the producer, and this will lower the water cut. So I get less water in the injector, more oil in the producer. Okay, I'm not sure if I'm going to cover the Rig Workover zonal isolation because I believe it's better to go through the questions instead. Or I'm not sure if you have time. There are a few slides only left, but what do you think, the SPE team?
It's okay. You can go ahead if you want to. If you don't have any remaining time, it's okay. You
No, for me, I
can.
have time, but I just want to check if the people, they
It's a
will
free.
still keep the same energy. If they don't, then I will stop. So it depends.
It depends on the
I
people,
will
so I
be
can't
checking
judge.
on the chat. Sorry?
It depends on the people, so I can't judge.
Okay.
If they want to leave, they will leave. If they want to stay, they'll stay.
Okay. Okay, no problem. I will go quickly through them. So just for you to have the full picture. Okay, so in terms of the rig workover, we say that when we need to have a workover rig on the well to do like some intervention that we could not done with the cold tubing. Quickly through them. Okay, so there is a technique or like that we are running with the rig workover, which we call it straddle packer. What does that mean? We have like tubing with two packers, and we are going to install these two packers across the water zone or the leak zone. If we have shallow leak zone, for example, here in this case we have like this is Nahar Umar, it's a water zone, high pressure zone. So the only technique that we could use to isolate it is to run two packers to isolate them. As I said, I will go through them quickly because I don't want to like spend a lot of time on them. The other usage of this packers that we could run it when we already pumped like cement and it did not work, like this case. So then we can run packer and make sure that this packer, the top will be set here, the bottom here, and then we can achieve 100% zonal isolation. So this technique could give us 100% success rate compared with the cement or chemical option. The other technique, which is we could do with the workover, when we have a bad cement between two zones, okay, and we want to like fix this the channel between two zones, so I can also go with a specific packer, drill pipe, and then we can like punch some perforation and then try to circulate the cement between the two zones just to make sure that all the cement will be covering the channel. This is the last slide, which is around the casing patch, which is a steel patch that will be run with the inflatable packer. So then this steel can expand to isolate certain zones. I believe that's it. Let's not go to the details. It's just like an overview because I already covered the details and all the details in the previous slides. Thank you very much. And any question? I'm sorry if I go quickly through the other slide, because to be honest, they need a lot. There are a lot of details that I hope if there was time to cover them.
If you have any questions, please write it in the chat box.
I hope you enjoyed the session.
I did, really, I did. Thank you for the information. So, if anyone has any question, if you want to wait for the questions, you can wait.
Yeah, I can wait. I really like to
So, I myself
hear my
have a
question.
question about coiled tubing. So, I've heard or I've seen, um, does coiled tubing work as a hydraulic fracturing uh,
Yes, yes.
tool? It does. So,
So actually, it's not the coil tubing itself. Good question, by the way. So now we are currently doing some of fracturing jobs with the Rig Workover and also with coil tubing, but it's not the coil itself. It just means that we can do the frac without a rig, but we don't need the coil to frac the well, because the chemicals, or it depends if it's acid frac or if it's a proppant frac, it will be pumped through the tubing itself. I don't need the coil to pump uh, proppant or acid through it. I can do all the operation from by pumping through tubing itself.
Okay, then. So about the determining the water zones, we do that by determining with coil tubing in PLT. And PLT we can run
PLT we
steel
can,
with the
it
coil.
depends. Good question, because the PLT we run it with the wire line. But in some cases, if the well ceased, ceased means that the well is not producing and I need to do nitrogen PLT. So then I can do the PLT with coil. So it depends on the well condition. But if the well is flowing nicely, no issues, the PLT should be run with wire line.
Okay, thank you, Mrs. Noor, for the great information. There's no further question. We are here. I'm really sad to end this session, actually. So we are
Thank
here.
you.
We have reached the end of this session. Thank you, Mrs. Noor, for the great and valuable information you provided in this session. And I hope you all the best, and we hope to cooperate in the future. And thank you, Mr. Noor, for the effort of making this happening. Thank you.
Thank you very much. I really enjoyed the session, and glad to hear the comments from you, and I hope the others they also enjoy it. Thank you very much.
Excuse me, Mr. Snow.
Yes.
There is some question in the chat. Firstly, Ayhan, he want to say thanks from Azerbaijan from your great efforts.
Oh, thank you.
And Mustafa Haytham, he asked why we using COCI3 with cement when mix.
So we are not using it, the calcium carbonate with cement, but in some cases we can pump the calcium carbonate with the cement. But it's not for us, at least in Rumaila, if we need the cement to be less compressive strength and to be moldable, we can use the calcium carbonate with the cement, but we usually don't mix them.
Okay, and the third question and the last from Kazım Riyad. How we can kill the well if we don't run tubing as kill strength?
We have a tubing in the well because as most of the presentation we were covering the cold tubing zonal isolation, and in the cold tubing we already have tubing in the well. We said for workover we will be taking the tubing out. For cold tubing the tubing is in place.
Oh, thank you. And finally, I want to say thank you very much for your for this season session. I am very grateful to have you in our events, IPES. Thank you, Ms. Noor, and hope
Thank
you all
you.
the best.
Thank you.
Thank you.
Okay. Okay, now I should stop sharing. I should stop.
Yes,
Okay,
yes, you can.
okay, start.